All right. Label your notes as amplitudes, periods, amplitudes, periods, and shifts.
Man.
Amplitude first of all, I'm going to say also known to you as the what, you guys? What was that number out front? Oh, also known as the radius. Yes, very nice. It's also known as the radius. But there is a formula for it, and we can find the amplitude by taking the maximum value minus the minimum value, and then what did we do to it? We divided it by 2. So the amplitude we could find, if you had a graph, you didn't have an equation, you could take the max minus the min divided by 2. If those are too bright for you, just
no.
you're okay. I know, it is kind of nice to have the sun shining in for a change, isn't it?
Yeah.
Can I flip pages, you guys?
No.
Yeah, I'm not done writing.
Boom, bam, pow, boom, 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 boom.
You want to switch pages already? Take it down the page.
You can flip. You know that's off a computer.
Oh, I realized that.
Okay. Periods.
Are you for us? Yeah. Oh.
A period is the number of, in this case we've been talking about degrees, but later on we're going to start talking about these things called radians. In fact, today we are going to talk about radians. The number of degrees or radians, so if you want to add that to your notes, or radians, they're not going to mean anything to you for a few minutes anyway. The number of degrees or radians
Say it.
that passes
Say it.
when a graph begins to what, you guys?
Ascend, descend.
Restart. Repeat is what I always say. When it begins to repeat. That's what a period is.
Sure.
And then a shift is just the number of units that a graph is translated up or down. I'm going to give you just a generic equation, and we're going to talk about each part of it using letters instead of numbers. Can I flip, or do we need another second?
You can flip it.
Need a second, okay.
I didn't get
No, no. What? What's up, bud? What's up, bud? Blood. Where'd you get that from? West side.
Alright, write this down. Y equals A, the sine of BX plus
God bless you.
D.
What's that for?
Now,
When
First of all, I've given you a sine curve, but everything that I'm going to say about this sine curve is true for a cosine curve too. So, yeah.
What about C?
Yeah.
Well, okay, C
Oh, I see.
is the value that we usually would add or subtract inside the parentheses.
Oh, I see.
But we are not talking about that this year. Okay, that's more
Let's
of a
see.
pre-calc topic that you guys will get into a little bit next year if you
Let's
take
see.
pre-calc. C would be considered a horizontal shift. All right. D is a what kind of shift? Vertical shift. And then, okay, let's start writing this. What is A?
You take it
A is amplitude, and no, it's not A because amplitude starts with A. It just so happens that this generic equation usually contains letter A, and amplitude happens to start with letter A. What is B?
The period.
It's not the period.
Well, the thing that goes with period.
It is the number used to calculate
The period.
the period.
Get at me, no.
So we need to make a note here, though. What did we do? What specifically did we do to find the period?
360.
The 360.
Excellent. So in other words, we had to take 360 degrees and we had to divide it by what? We divided by B. Okay, nice, guys.
360.
And D is the what? Is the vertical shift.
Blue.
All right.
All right.
Gosh, you guys must have a really good teacher because you seem to be really,
Oh
really
my
good.
goodness.
The best. You would just love her.
All right, y equals. Remember what I just said about how when I just was talking about the sine curve, all of this was still true for a cosine curve. So let's do a cosine curve. Let's do y equals 3, the cosine of 4x minus 2. What's the amplitude?
3.
Amplitude is 3, and I know we just did one of these, but we have never put them in our notes before. So the amplitude is 3. The period is 90. Very nice. So you take 360 degrees divided by the b value, which is 4. So 360 divided by 4 is 90 degrees. And then we have I've been calling it a shift. I'm going to be a little more specific here. It isn't just a shift. It is a vertical shift. What is the vertical shift?
-2.
It is -2.
Oh, wait.
We should probably graph this, shouldn't we?
No.
No, we shouldn't.
Okay, let's do it.
We don't need
Let's
to
not
graph
say we did.
Yeah.
We don't need to graph everything.
I'm so offended, you guys.
You so right, Jeremy.
You're
really don't.
I didn't mean to be rude.
You're not being rude.
Yes, I am.
just being truthful.
No, I'm being rude.
You're not being rude.
Yes, I am.
You're being funny.
No, I'm not. It wasn't a joke.
Ooh.
All right,
Everyone thinks what I say is jokes.
we're going to go up 3. And go down 3. And the reason I'm going to go up 3 and down 3 is because my amplitude is 3. My amplitude is 3. So does that mean, though, that I'm actually going to go up to 3 and down to -3? Why not?
Wait, what?
Why am I... The 3 here means that I should go up to 3 and down to -3, but I'm not going to go up to 3 and down to -3 because why? Because I have a vertical shift that is going to move the graph down 3 units. So remember when I showed you guys yesterday, when you graph these things, don't graph the vertical shift. Graph this thing without the vertical shift and then add the vertical shift. So let's graph 3, the cosine of 4x, just this part right here. So the graph should go up to 3, and it's a cosine curve. Remember, cosine curves start at their maximum value. How often should the graph repeat itself?
90 every 90 degrees.
Every 90 degrees. So I'm going to go over to 90 degrees. Go over to 90 degrees. Now, that means that at 90 degrees, I should be back where I started. So if I'm going to start here at 3, when I get to 90 degrees, I should be at 3 again. What is the minimum value? Without the
Minimum
shift,
value.
what's the minimum value? -3. And the minimum value is going to happen exactly halfway between these two maximums. So I'm going to go right to here. I don't even care if you label it. You just need to know that halfway between, you should be down here at a minimum. And then halfway between where my minimum is and where my maximum is, I have an x-intercept. And then halfway between my minimum value and my second maximum value, I have another x-intercept. Now this is what the graph would look like normally.
Yes.
But then we have a vertical shift that has to be added to it. So what do I do to every single one of these points?
Down 2.
You move them down 2 units. So take this 3, move it down 2, I'm going to put it here. Take this point, move it down 2, it ends up here. Which means now my graph is going to go as low as -5, not -3.
That's confusing, all these graphs.
It is, I agree. And
You should erase them.
you gotta maybe figure out what is the best method for you. Maybe it makes more sense to connect the first dots, but connect them maybe with a dashed line or something, and then you know not to use those points again. That might work better. Yeah, I would say on a test, whatever works. I mean, if it means you have to have twice the number of graphs on your paper, then have twice the number of graphs. It does not matter to me. Okay, and then of course, this is just one period. You could get multiple periods on a graph. In fact, these graphs go on infinitely far in theory.
Blue.
Right.